Thank you, Linda, and thank you everyone for joining me today for this webinar entitled Discovering Solutions to Researchers' Common Data Management Problems. Today's presentation is an exciting opportunity for me to tell you what we accomplished during the 5 years on the SEED project and how tools and services developed by the SEED project can be integrated into researchers' workflows and change the way researchers think about managing and preserving their data. But first, let's see. First, briefly, some background information for those who are new to SEED. SEED is a NSF DataNet partner created approximately 5 years ago to develop data services to allow researchers to more easily and efficiently manage, share, and collaborate around their data, and to better connect scientists' research workflows to the data preservation activities, such as data curation and publication. During the 5 years on the SEED project, we have worked with many research groups to understand their challenges around data management in order to build a set of integrated tools that can help them. And here are some examples of problems that we came across. For example, we saw that research teams, even those physically working at the same location, lacked access to effective collaboration tools and tools for sharing data across their teams. Related issues were about not having access to a secure environment which could provide appropriate data privacy and access controls. So instead, these researchers still heavily relied on shared file systems with no support for data annotation, collaboration or version control, and many still kept their data on personal computers and hard drives without adequate backup. Others struggled with supporting the large heterogeneous data produced by their projects. Next issue, so we know documenting your data during early phases of your research by people who know the most about this data is extremely important so that everybody on the team can fully understand the data. But yet, we have often heard about problems when it was hard to recover the knowledge about data because those with expertise have moved on to other projects, or maybe students who worked on collecting and analyzing data graduated and got jobs in other places. Next issue, for many researchers, the process of publishing data represented a huge burden, requiring a lot of time and effort. And indeed, traditionally, if you are depositing your data in a repository or an archive, most likely you will be required to fill out lengthy forms, re-enter your metadata that you have recorded before, and re-upload all your data files. Then you wait to hear the status of your publication request and hope that you've done it right. And finally, well, if you're a PI, the federally funded project, you most likely know about the big movement towards increasing public access to the results of federally supported scientific research, which includes research data. So now researchers must submit data management plans explaining how they can or how they will ensure future free public access to their peer-reviewed publications and data resulted from their research. So during our time on the SEED project, we encountered situation when teams had no clear mechanism for managing and maintaining data after their projects were completed and after funding was exhausted. And in opposite situations, researchers had their grants and data management plans accepted and approved by the funding agency, but had no mechanism for putting those data management plans into effect. So how can SEED help? SEED was created specifically to address issues around data management, access, and preservation that I just described. And we have studied the needs of many research groups in order to build a set of integrated services and tools that can be incorporated in researchers' workflows to help them more easily manage, share, describe, and publish their data. So SEED developed a whole suite of powerful and easy-to-use tools that are designed to support the entire life cycle of data management, from data collection to data publication in a long-term repository. And these services include project spaces, which are live, team-controlled, collaborative spaces to share, organize, and annotate data, and publication services represented in a streamlined workflow, which doesn't require a lot of extra effort to submit data sets for archiving in a long-term repository. SEED project spaces offer many powerful features that make working with and collaborating over data easier, and ultimately provide research teams with a mechanism to implement their data management plans in order to meet the requirements of their federally funded grants. So with on-demand creation of project spaces in SEED, anybody can have a project space, and it only takes literally a few seconds to get your project space up and running, and you would be able to access your project space securely from anywhere. So let me tell you about some features in SEED project spaces. You can bring your branding to SEED, your logo, your project's name. You can customize your project space homepage with a custom header image. Also, you can use project space in SEED as a central place for your project's data, and admins of project spaces can invite their teams and others to the project space in SEED and assign them to appropriate roles. So, for example, a user can be assigned an editor role. There could be more than one editor in a SEED project space. User can be an editor, contributor, a viewer, and those roles would define what those users could do with data in the project space. You can also structure your project space, give structure to your project space by creating empty data sets and collections to help organize your team's work in your project space. So, for example, data can be organized with data sets for different experiments or research topics. A data set is primary organizing structure of files for files in SEED. And an important thing about data sets in SEED is that data sets are the only publishable unit in SEED. Data sets can contain as many files as you want, and can be further organized with folders and subfolders. And some projects using SEED arrange their files into data sets with more, 2 or more levels of hierarchy. And we have examples of projects that have up to 12 levels in their hierarchical data sets. So again, your data set can contain folders for code and syntax, meeting recordings, notes, output, maybe paper drafts and literature. And I mentioned that you can create collections in SEED. Collections are different from data sets. They provide a way to bring together multiple data sets and their associated files, and basically in unlimited number of ways. So a single data set can appear in multiple collections. So one example, you can create a collection of data sets for everything you've done in a particular month of last year, let's say June. But then you also have a collection of data sets of all the work that's been done on a particular experimental site. So if there's a data set on the particular site that's been done of the work that's been done in June of last year, so that data set can appear in both collections. You can also easily drag and drop data of any format to seed and simultaneously organize your files in data sets. We have saw more than 100 different file formats being used by projects and seed. So basically, you can upload any data to seed. Seed provides you with thumbnails and in-browser previews to help you work with your data in your project space. There are viewers for many popular formats, including images and videos, which you can play right on the page. Seed provides page views for different document types, presentations, spreadsheets, and PDFs, and also helps you to see your geospatial data on the map. And in Seed, you can even bring multiple geospatial layers of data on a single map. And you can change opacities for these different layers of data to differentiate between them. So you don't have to download your data back to your computer in order to see what's inside your files. We know that researchers do not like to invest their time in curating their data unless they have to. And this is why data curation often doesn't happen until it's time to publish data, and only because a repository requires researchers to do so. So Seed aimed to change the situation by providing researchers with an incentive to be more involved with curating their data early in the research process. Seed offers tools for what we call an active curation, which is a practice of annotating data incrementally as this data are collected and analyzed, while the information about this data is still most complete. So teams can then incrementally refine this metadata over time. The concept of active curation in Seed is very important, and a lot of features and functionality in project spaces are built around that. Each project space is equipped with a set of metadata terms that teams can use to annotate data sets and individual files within those data sets. The majority of default metadata fields are from the Dublin Core metadata schema and support basic bibliographic information such as abstract, title, creators. But Seed recognizes that teams might want to add other terms that better meet their needs. So in Seed, teams can fully customize metadata options in their project spaces and even link to external control vocabularies such as ODM, Observations Data Model, or CSDMS, Community Service Dynamics Modeling, standard name vocabulary. In addition to metadata, researchers can add tags and comment on data. And Seed captures all this metadata, including auto-extracted metadata, which I will cover next, tags and comments, and packages them along with the data for publication. Moreover, all metadata, tags, and comments are fully searchable in Seed, and the search capabilities help scientists better manage data for their own use and improve team coordination around data. In addition, those teams that were engaged in early curation of their data see additional benefits when it's time to publish their data in a repository or an archive. The effort required of the researchers to do so at that point is greatly reduced because most of the required work to publish data has been already done. Instead of what sometimes can be quite a cumbersome process, in Seed, data goes through a seamless transition to become published products, which are, as a result of higher value, much richer, and can be more easily understood years from now by someone else who finds them and wants to use them. I mentioned outer extracted metadata. So in seed, each file within the data set is presented on a page that displays a preview. All of the user added metadata, and researchers can add further annotations on this page. In addition, seed allows researchers to see outer extracted metadata on this page. Metadata that's extracted from within the files. Seed captures and displays information about file formats, creation time, location. For example, seed extracts very rich metadata for images. And I have an example here to show you. So the information that it's able to capture about the equipment used to create the image, such as specs for the camera, camera settings, the date and time when the image was created, and GPS location where the image was taken. So next, let's look at data sharing options SEED has to offer researchers. So we talked about teams using project spaces in SEED to share data among themselves, and admins of project spaces inviting users, their team members, to the project space and assigning them to specific roles, admins, editors, viewers. But SEED also provides teams with easy options for making data publicly available without publishing, but also allowing researchers to formally publish data using SEED. So let me tell you more about these two options. By default, all project spaces in SEED are private and can only be accessed by members of that space, and data sets within a project space inherit access settings from the project space. So all content inside a private project space will be private by default. But SEED allows project space administrators and users with an editor role to override the default access level for individual data sets. In other words, admins and editors can switch access for individual data sets from private to public and back whenever they need. In addition, if you are an administrator in your project space, you have the authority to make your entire project space public, thus making all data in your project space publicly available. In that case, anybody will be able to view and download your data without logging into your project space. We had a project in SEED which used their project space that way as a portal to connect with the local community. Finally, researchers can use SEED to, as I said, formally publish their data in a long-term repository. So if you need a digital object identifier for citing your data in a paper, you should choose to formally publish your data in a long-term repository that has documented policies for preserving and archiving data. Note that SEED is not a repository. SEED provides preservation and archiving services through the network of existing trusted repositories that partner with SEED. And here are some examples of SEED partner repositories and some of their requirements for data deposits. So SEED is working with Ideals repository at the University of Illinois, IU SEED Cloud at Indiana University, and Open ICPSR at Inter-University Consortium for Political and Social Research, ICPSR, at University of Michigan. And you can see the the total, the requirements on total size, maximum file size, data set depth, how many folders down your data set can have. You can see that these repositories support Creative Commons license family. And you can see on your screen the types of data access that they can support. So in Seed, you can publish whatever you want and whenever you want, whenever you're ready. Seed allows you to assemble a package that includes the relevant pieces of your research which you want to publish. That can be a subset of data in your project space that includes associated metadata, tags, and comments that have been applied to that set of data. It can be the documentation about the data. It can be scripts that you used to get to your research results. And Seed provides you with a streamlined publication workflow, which you can see on your screen, that consists of 3 easy steps that guide you through a publication process that, again, doesn't require a lot of extra effort to submit your data for publication in a long-term repository. So when you're ready, you simply click on the Publish button on the datasets page in your project space, dataset that you want to publish, and a copy of that dataset is moved to a staging area, which conveniently comes with your project space. In the staging area, you can further prepare your data set for publication, for example, by adding more metadata. But any changes that you make to your data set in the staging area won't affect the live version of that data set that is still in your project space. And at any time, you can go back to your project space and continue developing that live version of your data set. And even over time, you can publish new versions of that data set. So if you don't know which repository may take your data, no worries. In the staging area, Seed provides a repository matchmaker service to help identify an appropriate repository for your data. So how does Matchmaker work? The Matchmaker performs an automated data and metadata review against repository requirements to find the most appropriate repository for publishing your data set. In a staging area, you will also receive instant feedback on why your data set would or would not meet the requirements of a given repository. You may see a message that tells you about a missing metadata that is required, or that your data set exceeded maximum allowed size, or that it contains a file in a forbidden format. If you see such messages from the matchmaker, this is actually great because you can quickly address these issues right there in the staging area. For example, like I said before, you can add missing metadata. You can remove file formats that are not allowed. So by comparison, during a traditional data deposit process, you would submit your data, go through the lengthy process of submitting your data, wait to hear back from the repository, and only then learn that there is something missing or wrong with your data set. Seed Matchmaker saves you time by informing you about potential issues before you even submit your data. So after you review the repository requirements, recommendations from the matchmaker in step 2, and possibly you had to address some issues, you can select a repository and click the final submit button. Behind the scenes, Seed packages your data and sends it off to the repository of your choice. Also, in the staging area, you can see status updates and sometimes messages from the repository. inviting you to complete additional steps that are part of the repository's publication process, such as maybe accepting repository's terms and conditions, agreeing to licensing terms. So when the repository publishes your data set, it will assign your publication a DOI, Digital Object Identifier, in most cases. And your publication will get a landing page, which, again, generated by the repository, which you can use to access your publication. You and others can use to access your publication. And this landing page will display the metadata and provide ways to download the entire package or just individual files of your publication. So the way, again, the way the landing page will look like largely depends on the repository that generates your landing page. And once your data set is published, Seed automatically indexes your publication's metadata and registers them with Data 1 so that your data is more broadly available and discoverable. Again, these are the metadata that you have added to your data in the project space, in your project space in Seed. And Seed captured and preserved all the metadata with, along with the actual data files to help with the reuse and discoverability of your data. So we're approaching the end of my presentation. What I wanted to leave a lot of time for questions. And in conclusion, I'd like to emphasize again unique features of Seed that make it a truly end-to-end data service, supporting researchers from data collection in management and Seed project spaces to publishing data in a long-term repository. Also engaging with early curation of data, researchers become more efficient in their everyday work and later see more benefits when they want to publish their data. Seed drastically reduces their time and effort required to publishing data. In Seed, researchers can submit their data sets for publication directly from their project spaces, can learn about repository options as well as repository requirements. And knowing your options for preserving your data can be very useful. It can allow you to make decisions about preserving different parts of your research. So you can choose, for example, to publish your final research results one way. You can later decide to publish a subset of your data that possibly is tied to a paper. You can publish that data in a different repository. And then you can choose to separately publish raw data from your project to make them available to those who want to look deeper into your research. So I hope that today's presentation made you curious enough to find out how Seed data services can help your project. So we invite you to try Seed project spaces and publication services. Before we switch to questions, I'd like to show Seed's contact information on your screen. You can learn more about Seed data services and find different help documentation on the Seed website, seeddata.net. In the future, we anticipate continued development of underlying technologies for Seed project spaces and publication services. Also, to mark the approaching conclusion of Seed's current agreement with NSF in the next few months, we plan to release a fully documented package of Seed's open source code that others could download, install, and build off of as they see fit. So make sure to subscribe to Seed updates to be the first to know when this happens. And you can also follow us on Twitter and Facebook. So let's see if we have any questions and use the remaining time to answer them. Let's see. So one question is there a size limitation for data sets added to project spaces? Currently, seed doesn't really have an official limit on how much data you can add to seed project spaces. Seed uses highly scalable horizontal technologies. So that means seed grows when usage grows. But we do ask projects to let us know if you're planning to add data in excess of 10 gigabytes, I think 10 gigabytes to your project space, because at that point we may need to start buying more space. So currently, so the question is, for clarification, are there more than 3 repositories available for submission, and how does a repository become linked to seed? So the 3 repositories that you saw on your screen, these are the repositories that currently, real repositories connected to seed. We also have some repositories that been connected to seed as a proof of concept. Like we experimented connecting seed to the National Data Service lab, and some of the U of M storage as additional storage. The way repositories connect to seed provides 2 options for repositories to connect to seed through seed RESTful API, and seed also provides what we call a reference repository software. And both options provide a lot of flexibility for repositories to connect to seed. With, for example, just to give you a couple examples, with RESTful API, seed's integration in a repository can provide basically just like a automated ingestion of data submissions to that repository, or additional steps in repositories workflow can be integrated within that process. Like, for example, when someone submits their data set to the Open ICPSR repository, Open ICPSR repository is an open repository that basically can take any data, but it has additional checks and balances to ensure that, for example, sensitive or identifiable information is not released through that repository. So even though seed provides that seamless ingestion process, data depositors are invited to log in into Open ICPSR system and complete additional steps, like to agree to terms of use and indicate if there is or there's no sensitive or highly identifiable information in that data. So next question. How does seed link or compare to Open Science Framework, OSF? Seed doesn't currently link to OSF, even though we've been thinking about that. As far as I know, features that make seed different from OSF, largely the sophisticated metadata management that seed provides. I think OSF currently doesn't allow researchers to customize metadata options. Also, seed allows to connect to institutional repositories. And a good example of that is the ideals repository at the university. No, well, yeah. Actually, no, I was going to say IU Seed Cloud repository, allowing researchers to seamlessly transition their data into the preservation environment in their home institutions. What kind of metrics are available regarding how often a data set can be accessed? Let's see. trying to understand exactly this question. Maybe.
Sorry, Anya we didn't talk about there being another person in the room, but my name is Dharma and I'm the Associate Director for the project, so I'm going to help Anya answer questions as well. And I take this question to be about usage metrics, about how often people have downloaded or used data sets, and we don't provide those at this time. We find that most of our users that are using the project spaces are keeping their data pretty closed within their groups. And it's up to the repositories as far as usage metrics on the archive versions of the data.
Okay, thank you, Dharma.
Yep.
Okay, so next question we have. Are you considering, or have you been approached by any Canadian organizations to participate in the program? Are we talking about, I guess I'm not sure if we're talking about researchers here or other repositories. I would say that at this point, it's largely been used by US researchers, right, and the national repositories partnering with SEED. So, but we would definitely welcome such opportunity, definitely. Is there any provision of services for licensing and copyright issues associated with data and publishing? I think largely SEED leaves this prerogative for the repositories that SEED provides. SEED is flexible enough to allow researchers to have their checks and balances and address these issues on their end, right, Dharma?
Yeah, I mean, researchers can apply a CC license to their data within SEED, and that information gets delivered to the repository to deal with in the way that fits with the policies that they have about that.
Okay. Is there a size limit on the data files or total amount of data? Okay, so it's a similar question that we had before, right? So just to quickly repeat the answer, no official limit, but we do ask you to let us know if, at this point, I think 10 gigabytes, if you're planning to upload more than 10 gigabytes, please let us know. Does the project space tool read statistical data files, SPSS, and what metadata does it extract automatically and what has to be entered manually? So you can upload statistical data files to SEED. Currently, I don't think we have working viewers and extractors for this type of files.
We can read tabular data, so if it's in something like CSV, that does display. But if it's in one of these statistical package formats like SPSS, we don't display a preview of it yet.
But if there is a demand for such viewers and extractors, we certainly can look into it and see if there is an existing application that we can connect to SEED to do that. And in terms of metadata that automatically extracted, I think the file format, the size, the time when the file's been created, there's kind of like a standard extracted automated metadata that you will be able to see. And again, like the viewers, if there's any additional extractors out there that we can connect to SEED to help extract more metadata, we can certainly look into it. Is this cloud-based, or where is the data stored while it's in SEED? As far as I understand, the data...
it is cloud-based, and the data lives on our disks at NCSA. So the data is stored with SEED while it's in its active state, and then if you guys initiate publishing in the repository, that's handled by the repositories.
Thank you, Dharma. How can collaborators programmatically access data in a project space before publication? So SEED, again, provides such flexibility to teams working their project spaces to invite others to their project spaces, and potentially you can invite additional collaborators to your project space and give them access to specific parts of your data before publication, right?
Yeah, it sounds like this question might be about how people can programmatically access data, so that how they can use like code to read and write data from the files in Seed. I mean, I'm guessing that that's what that means.
Not sure.
And right now we don't really have a direct way to do that, but we certainly have the capability of building tools into that. So one tool that we had on our previous iteration of this platform allowed people to read and write using R. And our tool is built that people could connect such things using the API, but we haven't developed those specific capabilities ourselves. But we welcome opportunities to collaborate with people to do that.
What is the security for Seed, and is it appropriate to store sensitive data? Well, this question comes a lot, and well, a little bit of background information. Seed is still operating two different generations of software. We have Seed 1.5 project spaces, and last year we released next generation of Seed data services, Seed 2.0. So Seed 1.5 went through extensive security review, but Seed 2.0 is still under active development, and such a review hasn't happened yet. We do anticipate that to happen at some point in the future, but currently, if you have data, sensitive data, which release accidental or due to some malicious cause, can have significant consequences. We do not recommend using Seed for such sensitive data, Seed 2.0 for such sensitive data. You mentioned Seed's current contract with NSF is ending soon. What is the sustainability plan moving forward? So maybe I can, Dharma, answer that question.
Yeah, I'm happy to answer that. So the sustainability of anything that's archived in the repositories is subject to those repositories' terms, and that's why we partnered with them for the long-term sustainability of data that's being archived. So that persists no matter what happens with us. In terms of our own sustainability plan, we're still in the process of trying to consider what's going to happen at the end of the current grant period. But we do anticipate continued development of the underlying technologies that build the project spaces. And also at the end of the project, we plan to release a fully documented set of code, I think as Anya said at the end of her presentation, that can be used and built upon as well. But I would say this is something that we are planning for right now, and we're not exactly sure of what the plan is after. But we do know that that the underlying technologies will continue to be developed, and that we are going to release it in such a way that people could build off of it if they wanted to. Next question.
Okay. How much functionality is there within Seed for editing and running analysis? Currently, you cannot change your data inside Seed. In Seed 1.5, we used to have like a way to connect R to Seed and move your data to R and back and capture things that have been done to manipulate the data in R. We haven't done anything like that for Seed 2.0, but again, there are possibilities that this can happen once we have a group that's interested in such capabilities. So yes, okay, let's see. You list Brown Dog, Data One, EarthCube, Geosemantics, and National Data Service, and Terra Populars as service partners. I think the demo showed that Data One provides a listing of published data, but could you speak to the role of these other partners? Dharma, can you help with this question?
Sure, I can talk about some of these. Terra Populus, I don't think is a service partner, but they have partnered with us on demoing particular capabilities. Mm-hmm. So that's why they're on there. Brown Dog is an underlying technology that we use for the extractors. So a lot of what Seed is built upon technologies that are developed at NCSA at the University of Illinois. And Brown Dog is one of them. Another one that I'm not sure came up in our presentation is called Clouder. And again, I mean, that's part of our, going back to the sustainability question, one of the reasons why we partnered with all of these groups is to kind of ensure the long-term sustainability of the underlying technologies, and that's an example of that. Data One is a registration service, so we register all of our metadata with them. The EarthCube Geosemantics, they have also done developed some tools that we make use of for the geospatial previewing, I think, mostly. Mm-hmm. And the National Data Service, that is a consortium of people who are interested in building services and technologies for data infrastructure. And so we're one of the many groups that is part of that group that comes together around connecting all of these different pieces that people are developing to create, more national scale infrastructure. And I think that's all that was directly questioned.
Mm-hmm. I think so.
So we'll go to the next question.
How long is seed funded for, and what will happen to the site after funding ends? I think Dharma addressed this question before.
Yep.
So we'll move to the next question. Clarification only. Canadian organizations. I see. The Canadian Association of Research Libraries.
This is a clarification question about the Canadian organizations question, asking about I think whether we've talked to anyone at the Canadian Association of Research Libraries, Portage Project, or OCUL Scholars Portal. And
we have not. Yeah, but it would be great to collaborate.
Yeah.
Is there a full set of APIs or just the functions necessary to tie in a repository, load data into project space, set tags, etc.?
There is a full set of APIs to do all kinds of things. I probably am not the person to talk to about the specifics of this. We have technical people that we would be happy to put you in touch with. But there is definitely the ability to use the API to load data to a project space en masse instead of just using the web browser. And we've built it such that that capability is there. I think a lot of it is subject to your permission. But yes, there is a full set of APIs.
Mm-hmm. Okay, is this the last question?
I think that's all. Yep.
Okay, should we wait a couple seconds if someone types in a new question? Okay, well, Seed's contact information is on your screen. Again, you can see the website, seeddata.net. Please email us if you have any additional questions or would like to discuss any of these topics further. We'll be happy to answer and provide more information. Also, as I mentioned before, you can subscribe to Seed updates on the Seed website. And again, we encourage you to try Seed project spaces and publication services, and you can start your project space in just a few seconds. Going through the Seed website, project space tab in the main navigation. So I guess we're gonna conclude today's presentation. Thank you everyone for attending, and have a great the rest of your day. Thank you.